Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video for subject Electrical Circuits 1 code BEV 10303, and in this video we are going to discuss on topics of chapter 4, which is circuit theorems. Okay, so the list of contents that we are going to cover for this chapter is a superposition theorem, followed by source transformation theorem, okay, and then we are going to see the Thevenin's and Norton's theorem, and the last part is the maximum power transfer theorem. Okay, so basically why do we need all these theorems here? If you still remember, in the previous chapter 3 we had learned on how to analyzing the circuits using the Kirchhoff law and the Ohm's law. Okay, however, this technique has a problem when you are going to analyze a large and complex circuit, okay, because it will involve some of the tedious computation. Okay, so in order to handle the complexity, so engineers over the years have developed all these theorems in order to simplify the circuit analysis. Okay, so that's the reason why do we need to learn on the circuit theorems. Okay, in this video, which is a part 1 video of a chapter 4, we are going to cover on topics of superposition theorem, okay, and then for the rest will be covered in the next following video. Okay, so let's move to the superposition theorem. Okay, if you have a circuit that have 2 or more independent sources, so one way to determine the value of a specific variable, whether you are going to determine the value of some voltage or you are going to determine some value of the current, usually we advise you to use nodal or mesh analysis in chapter 3. Okay. So another way is to determine the value of the specific voltage or current. Okay, we can use a superposition theorem where we are going to determine the contribution of each independent source to the variable, and then after that we are going to add them up later. Okay, so the approach, we call it as a superposition theorem. Okay, so it means that the superposition theorem say that the voltage across an element in a circuit is the algebraic sum of the voltage across that element due to each independent source acting alone. Okay, or it can be also said that the current through an element in a circuit is the algebraic sum of the current through the elements due to each independent source acting alone. Okay, so the keyword here is each independent source acting alone. Okay, so that's the concept of the superposition theorem. Okay, so how to apply the superposition theorem? So first thing we need to do is we need to consider one independent source at a time while other independent sources are turned off. So what does it mean by turn off? Okay, turn off meaning that if you have a voltage source, you assume it as a short circuit. Okay, because when V equal to 0, we consider it as a short circuit. For current source, if you have a current source, it means that you need to turn off the current source. So I will be equal to 0. So when I is 0, we will consider it as an open circuit. All right. And then once you consider your independent source at a time, okay, and then the dependent source are left intact, okay, because they are controlled by the circuit variable. So you just turn off your independent source, but you just leave your dependent source. You don't need to turn off your dependent source. Okay, all right. So the steps on how to apply the superposition theorem is, okay, so first thing what you need to do is you need to turn off all independent source except one source, okay, because you need to leave only one at a time. Okay, and then after that you need to find the output, whether it's a current or it's a voltage. So this is up to the question. Okay, so you just find the value of the current or value of the voltage due to the active source using technique that covered in the chapter 2 and chapter 3. So meaning that maybe you are going to apply a voltage divider rule, or maybe current divider rule. Maybe you are going to apply the mesh analysis, Kirchhoff analysis. Okay, so it depends on the type of circuit that you get. All right, and then after that you need to repeat the step 1 and step 2 for each of the other independent sources. Okay, so because let's say you have a 2 source, so you need to do 2 times let's say you have 3 sources, then you need to repeat 3 times. Okay, and then finally, you need to find the total contribution by adding algebraically all the contributions due to the independent source. Okay, so let's say you have 2 source, then you are going to add the contribution by the 2 source. If you have more, then you need to find the total contribution based on all the independent source available. Alright, so let's move to the following example. 4.1. Okay, so based on this circuit, use superposition theorem to find V. Okay, so you need to find the voltage across the resistor 4 ohm. Okay, so here you have a independent source. So you have a voltage supply of 6 volt and you also have a current source of 3 ampere. Okay, so what you need to do in order to use the superposition theorem, you need to turn off the source one by one. Okay, so first of all, you need to turn off your voltage supply, okay, and then after that you turn off your current supply. Okay, so the solution for the example, so step number 1, we short circuit the voltage source first. So here you have a voltage previously you have a voltage source here, so when you turn it off, so meaning that you make it V equal to 0, so you just short circuit here. Okay, and then after that you can use the current divider rule. You need to find the value of a V here. Okay, so in order to find the V, you have the value of R. So you can just find the value of I first. Okay, I that flow through the 4 ohms. So based on the I, you can find the value of V. So how to find the value of I? You can use the current divider rule. So the current going through the resistor 4 ohm will be equal to 8 over 4 plus 8 multiplied with the current source, which is 3. Okay, so the current that going through the resistor 4 ohm is equal to 2 ampere. Okay, and then once you know your I, then you can apply your Ohm's law where V equal to IR. So R is 4 ohm, I 4 ohm is a 2 ampere, so 4 multiplied with 2 will be equal to 8 volt. Right, so this is the value. We call it as a V prime lah. Okay, because we consider V will be equal to V prime plus V double prime. Okay, so V prime is a contribution based on the current source only. Then after that, we go to the step number 2. We are going to open circuit the current source. Okay, so here you put back your voltage source, but you remove your current source. Okay, so when you consider your current source is off, meaning that I is equal to 0. I is equal to 0, so it means your circuit is an open circuit here. Okay, and then you need to find the value across 4 ohm. Okay, so based on this, you can just apply your voltage divider rule. Okay, so you need to find the voltage across 4 ohm. So here you call it as a V double prime. Okay, V double prime will be equal to 4 divided by 4 plus 8 multiplied with the voltage source, which is 6 volt. Okay, so you get V double prime will be equal to 2 volt. Okay, so finally, the last step, you need to add on all the contribution of each of the sources. Okay, so you have V will be equal to V prime plus V double prime. So just now you have 8 and here you have 2. 8 plus 2 will be equal to 10 volt. Okay, alright, and then we just move to the next example. So this example, based on the circuit, okay, you need to find the value of I naught in the following circuit using the superposition theorem circuit. So here you have a independent source. Here is an independent source, but here you have a dependent source. Okay, so you need to remember, you just need to apply the superposition theorem only on the independent source. Okay, you just turn off this one by one. Okay, you can turn off this one by one, but for the dependent source, you don't need to turn it on. You just leave it there. All right. Okay. So the solution for the example, step number 1, you short circuit the voltage source first. So here just now you have a voltage source. You short circuit it because you are going to turn it off. Okay. And then you can apply the mesh analysis to obtain the I naught prime. Okay, so basically you need to find the I naught. So because you have a 2 independent source, so I naught will be equal to I naught prime plus I naught double prime. Okay, so here you are going to find the I naught prime first, right? So this loop, we consider it as a loop number 1. Okay, so here is a loop number 2. Okay, we consider here I2. Here is I1. Okay, here you have a loop number 3, so you have a I3. All right, so for loop number 1, loop number 1. So I1 will be equal to 4 ampere, okay, because I1 will have the same direction as the current source. So I1 will be equal to 4 ampere. For loop 2, here you have a loop 2. You can apply your mesh analysis, okay. So for just like usual, you just apply your polarity first based on the mesh current. So here you have a positive, negative, okay, you have positive and negative, okay, because you have I1 here, so here positive and negative. You have a I3 here, here is a positive, negative, and positive, negative. Alright, so for loop 2, here is your loop 2, you have 3 ohm multiply with I2 minus I1 plus 2I2. Okay, here you see the negative terminal, so negative 5I0 prime plus 1 multiply with I2 minus I3 equal to 0. Okay, and then you can further simplify this equation, and then you can get negative 3I1 plus 6I2 minus I3 minus 5I0 prime equal to 0. Okay, so this is considered as your equation number 2. Okay, and then after that you need to apply your KVL at the loop number 3. Okay, for loop number 3 you have 1 multiply with I3 minus I2 plus 5I0 prime plus 4I3 plus 5I3 minus I1 will be equal to 0. Okay, and then after that you can further simplify the equation. Get negative 5I1 minus I2 plus 10I3 plus 5I0 prime equal to 0. So this is considered as your equation number 3. Okay, you if you refer to here, okay, here you have a, let's say you consider this as a node O. Okay, so you have a direction of I0 here. Okay, you have also here is a I3. Okay, here you have a I1. Okay, so basically you can apply KCL at the node 0. Okay, so here you can see that I3 plus I0 will be equal to I1. Okay, so based on your KCL, total I in will be equal to total I out. Okay, so I in will be equal to I3, I out will be equal to, I3 plus I0. Okay, so equal to I1. Okay, in this case, I1 is equal to 4, right? Okay, so KCL at node 0, you get this equation, right? And then after that, you just substitute your equation number 1 and equation number 4 into equation 2 and 3. Okay, so after you substitute, here is your 4 is your I1. Okay, just substitute here is your I3. Okay, and then after that, what you get? 6I2 minus 4I0 prime equal to 16. Okay, so based on equation, this is your equation 2. Okay, this is your equation 3. You just substitute the value of I1 and I3, and then finally I have the equation of negative I2 minus 5I0 prime equal to negative 20. Okay, so you can just solve these two simultaneous equations, okay, by using, depends on if you are going to use a Cramer rule, or maybe you can use your own calculator, or you can just use the matrix. Okay, and then finally you get I0 prime will be equal to 3.06 ampere. Okay, so this is your I0 prime. So remember, you need to find I0. I0 will be equal to I0 prime plus I0 double prime. Okay, so let's move to the second step, where we are going to open circuit the current source. Okay, so here you have a current source, you just open it. Okay, and then you can apply mesh analysis to obtain the I0 double prime. So this is your considered as your loop number 4. Okay, here is your loop number 5, right? So for this loop, you because it left open here, so that's why you don't need to, this is considered as an open circuit. Okay, so you don't need to apply mesh analysis here. Okay, so we do one by one. For loop number 4, we apply the mesh analysis. So before that, you just assign the polarity first. Okay, so you have a, based on the mesh current I4, here you have a positive, negative. Okay, here positive, negative, and positive, negative. So based on the I5, here will be positive, negative. positive, negative, and here is a positive, negative. Alright, and then for loop number 4, you apply your KVL. So starting from here, you have 3i4 plus 2i4. See, you have a negative terminal, so that's why minus 5i0 prime, 5i0 double prime, okay, double prime, plus 1 multiplied with i4 minus i5 equal to 0. Okay, and then after that, you just further simplify your equation. You have here 6i4 minus i5 minus 5i0 double prime equal to 0. So here is considered as your equation number 7. Okay, and then for loop 5, you apply your KVL. So here you have 5i5 plus 1i5 minus i4 plus 5i0 plus 5i5 minus 20 equal to 0. Okay, and then after that, you can just further simplify your equation. You get minus i4 plus 10i5 plus 5i0 double prime equal to 20. Okay, and then based on the circuit, you know that i5 will be equal to negative i0 double prime. Okay, so here you have a i5. Okay, so i5 will be direction like this, and i0 will be this direction. So that's why i5 will be equal to negative i0 double prime. Okay, so you just substitute this into here and here. Okay, because you just have a 2 simultaneous equation. Okay, but you have a 3 parameter here, 1, 2, and 3. 1, 2, and 3. So that's why you need to substitute here, so that your equation will be left only with 2 variable only. Then finally you have 6i4 minus 4i0 double prime equal to 0. Okay, and then after that, based on your equation number 8, where you have negative i4 minus 5i0 double prime equal to 20. Okay, so here you have a 2 variable only. So that's why you can just solve your 2 simultaneous equation by using either Cramer rule, or you can also use a calculator or matrix. Okay, so finally you get i0 double prime is equal to negative 3.53 ampere. Okay, so here is your i0 double prime. So finally you need to find your i0. Okay, so i0 will be equal to i0 prime plus i0 double prime equal to 3.06 minus 3.53. So finally the answer for i0 will be equal to negative 0.47 ampere. Okay, so remember, the tedious work, okay, it actually depends on how many sources that you have. Okay, based on this example, you have 2 sources. Okay, so that's why your i0 will be equal to i0 prime plus i0 double prime. Okay, let's say you have maybe you have 3 sources. Okay, so what you need to do, you need to find i0 will be equal to i0 prime plus i0 double prime plus i0 triple prime. Okay, so basically the superposition theorem do help in order to reduce the complexity of the circuit, but it will require more works. Okay, because you need to turn off all the sources one by one. All right. So that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay, bye.